Anyway, thank you, Mike. I'm glad to be here, and I appreciate the opportunity to bring you up to date on what DGGS is doing with regard to statewide mineral assessment in general, and more specifically what we're doing with this strategic and critical minerals program. And you might have been able to tell from the bio there that my expertise is not in mining geology, it's in engineering geology. But as deputy director, I've had to become probably just enough familiar with this to be dangerous. But people that are running this program are traveling and other commitments, so I'm happy to be here on behalf of DGGS to present this to you. So here's what I'll talk about. I'll start with an introduction, talking about Alaska's mineral potential in general, and our program to assess that potential statewide, and then more specifically talk about Alaska's potential for strategic and critical minerals, and what we're doing on this strategic critical minerals project that we've been funded recently to do, and talk a little bit about our future work. So any geologist in Alaska knows very well that Alaska is made up of this big stack of terrains that have been hauled there by this conveyor belt in plate tectonics, with the Pacific plate moving northward and bringing all these terrains and smashing them into the state, well, since the probably early Mesozoic. And knowing this geology helps us understand the mineral trends. The base metals tend to be concentrated in this band indicated in blue here. Copper, lead, zinc, a lot in the Wrangellia terrain, as well as, of course, up here in the Southern Brooks Range. Red Dog is up here. Precious metals, their biggest concentrations seem to be in the Yukon-Tana uplands belt here between the Denali and Tintina faults, but here again, other places as well, southeast, of course, southern Alaska, and up here on the Seward Peninsula. Strategic minerals and rare earths, they tend to be congregated along the fault systems. Again, here along southeast Alaska, along the Denali Fault, Tintina Fault system up here, and up here again in northwest Alaska. Then of course we have these big basins where we get oil and gas and coal resources. So it's a tremendous resource endowment. We're very fortunate in this state, and a lot of this, of course, is still untapped. There's still a lot of potential there. But understanding a bit of this geology is what helps us focus our inventory efforts and assess where the potential really is in the state. So what's DGGS been doing to address this potential? Wish I was able to see this without looking back at it. Since, of course, DGGS has been doing mineral resource geology for quite some time, since it was started back in the early 70s. But we began this comprehensive inventory program in the early 90s that we call the Airborne Geophysical Geological Mineral Inventory Program, or AGGMI. And so we're looking at this. There's about 40 million acres of state land that has high mineral potential. And since 1993, we've spent a bit over $14 million doing airborne geophysical surveys and geologic mapping, particularly on state land or state interest land that has high perceived mineral potential. We've shot almost 13 million acres of geophysical surveys, including just this past year, and we've done geologic mapping, looking at mineral resources on about 5.5 million acres. So with 40 million acres state land with high mineral potential, we still have quite a ways to go. Specifically with regard to strategic and critical minerals, we started this program a couple of years ago at the request of the governor and funded by the legislature, starting with rare earth elements. We got an initial capital improvement project here of just under $500,000 in FY12, last fiscal year. And then about a year ago, we were asked to expand that project, a comprehensive project looking at the potential for all the strategic and critical minerals. And so this past year, we received in FY13 a little over $2.7 million capital improvement project. And now there's another request for about the same amount in the governor's requested budget for FY14. We start by drawing on whatever existing information is out there that we can put our hands on. And there are a lot of sources of this. This is just a few of them. This is the data in the Alaska Resource Data files that anybody has access to on the web. A lot of data compiled in a program that many of you probably remember called Madeira, the Minerals Data and Information Rescue in Alaska program that ran for about 10 years on congressional appropriation. Industry data that's been donated, starting with a lot of SERI data, but a lot of industry donations here. This data now is now available to the public on our website. Private industry data that's been donated to DGGS. It's not largely the data itself. It's an index of that data, who owns it, where you can go get it, and what's contained in it. So, and this is both industry and public data. Now, this started as a file called ACMIDI, the Alaska Mineral Industry Data Index. We've changed that name since it now includes a lot of public data as well. It's called the Alaska Geologic Data Index. And then existing publications, in addition to our own publications that are available to our website, we have a complete or nearly complete collection of all USGS reports for Alaska, as well as U.S. Bureau of Mines and BLM reports, and the reports from the Mineral Industry Research Laboratory at UAF. So here's a program that we've been conducting over the past 20 years or so. The AGGMI program, and if you were paying attention to the geology, it'll make sense to you why so much of our work has been in this area here, in this concentration of where the precious metals particularly tend to be concentrated in this belt between the Denali and Tintina faults, but also studies over here on the Seward Peninsula. The blue are areas where the state has run airborne geophysical surveys, state-funded surveys. The yellow, where we've run surveys funded by the Bureau of Land Management. And the red indicates areas where we've done geologic mapping. So you'll see what we try to do is we run an airborne geophysical survey first, and then we go back sometime later and we do the geologic mapping using the airborne geophysics as an aid to that mapping. And I'll show you an example of that here, here in the Salch River Pogo area. This is an old regional air mag map that was done back in the 70s. And this is the same area that where we resurveyed that area at much higher resolution in 2000. Obviously, much more detail. The Pogo deposit is somewhere around in here. And the resulting geologic mapping, again, this is the old, the former geologic map from the USGS back in the 70s. And this is what we were able to do by detailed geologic mapping and using the airborne geophysics. It is particularly useful in so much of Alaska that's covered by vegetation and quaternary deposits where you don't have outcrops. we can tie that bedrock geology together using the airborne geophysics. And then we put that data out in a variety of ways. You can search our publications database for the results of all those surveys. We have an extensive library in Fairbanks. Virtually all of these reports are online. We store samples here at the Geological Materials Center in Eagle River, publish geologic maps and the geophysical surveys. And we also have databases like this, the geochemical database of rock samples that you can access directly, several databases like this that are available through the DGGS website. So now specifically with regard to strategic and critical minerals, let's first look at what we know of the potential for those in Alaska. And I know many of you have seen this. There is a more or less official list of what we mean by strategic and critical minerals. And this is the list published by USGS a few years ago. Not only the rare earth elements and the platinum group elements, but these other 14 elements as well that are considered critical for the nation's supply for technology and defense, computers, and alternative energy. And of course, this is a dynamic list. As technology changes, the needs change as well. So this will change over time. Looking at this list of minerals that are typically needed for technology and other purposes in the U.S., this is a diagram that shows what the U.S.'s dependence is on these minerals. So about the top 20 of these or so are minerals or elements on which the U.S. is 100% dependent. And it goes down from there. The red are minerals or elements that have current production in Alaska. The green has had past production, indicating probably some potential for future production. That's the green, and the blue is potential. It's known in Alaska and it has future potential. So then if we look at that subset of these that are the strategic and critical minerals that were just on that list I just showed, there's about 8 of these on which the U.S. is totally dependent, and all but one of them, the U.S. is more than 50% dependent. But clearly all of these, they either have had potential in the past or current potential, or they've had production in the past, or they have some future potential in Alaska. 2 years ago, we published this report, Information Circular 61. That was a summary of all the data that we could compile on just the rare earth elements in Alaska. This is available at our booth over here. And that publication included this map, which showed 71 localities of known rare earth occurrences, as well as these areas that showed high values of uranium from the NURI data set, which would indicate also potential for rare earth elements. And of all of these, other than Bocan Mountain here, none of these have been evaluated to the extent we really know what the resource is there. And that's part of the goal of this program, to assess as many of these as we can to get a better idea of their potential. And this is the whole set of strategic minerals that were from that list. The reds here are the localities that were just on the previous map, and then all of the other localities in the state that have something from that list. So there's potential, appears to be potential all over the state. The white squares indicate areas where we have samples at the Geologic Materials Center, and we've already pulled many of these to reanalyze them for rare earths and other strategic minerals. So this strategic critical minerals project that we started in FY12 with the Rare Earth Elements Project, and we greatly expanded it this fiscal year. The areas that we've looked at now over the last couple of years are here. Two airborne geophysical surveys in this area here. East Moran project up here. This was in 2011. Ray Mountains project here in this past summer in 2012, and also in 2011 we did a study down here at William Henry Bay in southeast Alaska. And first, looking at these airborne geophysical surveys, these are the two here, and these are both adjacent to former geophysical surveys. The Donlin survey here is adjacent to the state-funded Iditarod survey from some years back, and the BLM-funded surveys here at Antioch and Sleetmute. And then the Farewell survey here is adjacent to the Styx River survey that we just completed a few years ago. This Donlin area survey has been completed. The data should be available this spring. And here in the Farewell survey, this one isn't quite completed yet. The Donlin survey is both mag and electromag surveys. This one included those two plus radiometrics. Radiometrics can't be flown when the ground is wet or it's snowing or raining. So we completed part of this survey this past fall, and we're going to be back in there to complete the rest of this survey this spring, and this data will be available later this year. So of the field surveys that we've done now in 2011, 2012 are in these locations. Starting with the, back up here, this Western Moran survey here, just west of Tanana. The green here is the boundary of the geophysics that we flew a few years ago. And then in 2011, we were here in the Eastern Moran area doing geologic mapping that was supported by the federal state map program. And then in 2012, was that 2011? We were in here doing stream sediment sampling in the Western Moran area. When we were over here in Eastern Moran, there's known gold localities there, and we encountered some especially high values up here along this fault system here. And then here in the Melizitna Pluton area, streams sediments showed some quite high rare earth values here. And this data is available in these reports. Now moving to the northeastward, this is the study we did in 2012. Moving here from Moran up this trend, this is the Ruby terrain. And we're following the ruby batholith plutons up into the Ray Mountains area. This is about 175 miles north of Fairbanks, a total area of about 3,500 square miles. And this extends all the way from the Yukon River here up to, about Prospect Creek up here on the north end. This weird outline here is the boundary of state-selected land. It's nearly all BLM land, but it's all state-selected with the exception of this area here, which is Doyon land. And the green here are claims, primarily Contango and Eucor that have these claims. The geology here, we've got the ruby pluton, plutons in here with the associated with ruby batholith, and then these are all around 100 to 110 million years old, and then some tertiary alluvial deposits here, as well as quaternary alluvium that are interesting targets for the rare earths and other strategic minerals. There's a lot of work that's been done here previously, some private exploration back in the 70s and 80s, a lot of work by USGS sampling, and then the NURI sampling. Bureau of Mines did a lot of work in here in the 70s and 80s, and BLM as well in the 90s, and there's current exploration going on in here by Doyon and Contango and UCOR. So we had all of this, a lot of this data to draw on. We have received some sample donations of data from Doyon and from UCOR here as well. And so this indicates locations of lode deposits here, gold placers. This is the Prospect Creek area up here, as well as a few tin occurrences as well. Here's the crew we had out here this past summer. As many of you know, we lost some geologists about a year ago due to resignations. People going to the private sector, and 3 people out of this minerals program. So we had to kind of scramble to put a program together this past year. Larry Freeman of DGGS headed this up. We hired some temporary geologists, Amy Tuzolino here, Colby Wright. No, he's a student intern. Colby's a student intern. Eric Bachman is a temporary geologist. Bill Wiley here came up from the University of Georgia for that program last summer, and Michael Blessington was also a temporary geologist for us, and we contracted with Reiner Newberry from UAF, helicopter mechanic and pilot Bob Dunbar here. This is Casey, can't remember his last name, with Jubilee Mining out of Colorado. This is when the crew was visiting the Jubilee operation up there at Prospect Creek. A lot of sampling around the area. We're not geologic mapping here. A lot of stream sediment and pancon samples indicated by the triangles here. Bedrock samples indicated by the circles. Collecting for trace elements and rare earth element geochemistry, and just trying to characterize the whole area for its rare earth and strategic mineral potential. One of the more significant things that came out of this study, just looking at the bedrock samples here, the rock samples from the ruby batholith, if just looking at this diagram down here, using cerium as a proxy for rare earth elements and plotting that against rubidium as an indicator of fractionation, what the geologists have found here, and this pretty well confirms earlier studies, is that the values of cerium decrease with increasing fractionation. And we see that in the Ray Mountains pluton here, these samples, Siflamenket pluton here with the green triangles, and down in the Malosi area, all decrease in cerium with increasing rubidium, showing that these elements are not being concentrated with increasing fractionation. They're dropping out, and so the likelihood of them coming out in hydrothermal deposits and veins and so on is probably pretty low. And this trend continues. If you just look at the light rare earths here, that is consistent with that trend. And these elements, the light rare earths, appear to be getting concentrated in monazite, and the heavy rare earths in xenotime. And the map over here shows total rare earth concentrations here with the size of the square, and then looking at the ratio of light rare earths to heavy rare earths, showing areas where the light rare earths are concentrated in the areas, the locations with the yellow and orange squares, and the greens indicate areas that are enriched more in the heavy rare earths. But looking at the pan-concentrate samples from the alluvial deposits and colluvium, the values for rare earths get quite high here. And again, the reds indicate concentrations of the light rare earths. The greens are more the heavies. But what it seems to be telling us is that the targets are more likely in the alluvium with the placer deposits than in the bedrock. In contrast to where you normally go to find the mother lode in the bedrock, here it looks like the better places to go may well be the alluvium, where they're further concentrated as placers. Down in William Henry Bay, which is it's directly across Lynn Canal from Berners Bay, just up north of us here a little bit. There are a couple of rare earth localities that are shown on that map that are up in this area. This is a boundary of state land down here, so the interest here was to see whether there's any indication of rare earths or other strategic minerals in this state land area. So Melanie Worden here made a trip down there in 2011 and did some sampling. And of course, field work is always like this in Southeast Alaska, right? The rare earths are elevated here, up here in this pluton and associated dikes, but not really high. But what she did find, some discoveries of some very high gold concentrations in the bedrock here. The red indicates bedrock. The blue values are from stream sediment samples. So both here in the bedrock within the state land, there's up to 500 parts per billion gold. And in a stream sample up here to the north, almost 2,000 ppb of gold. And here's a sample of the gold-bearing quartz. So in addition to those samples in the areas that we have done field work, we also, there's a tremendous number of samples that have been collected, especially by USGS, indicated by all the black dots here, that we are working together with USGS under a cooperative agreement to go back and reanalyze a lot of these samples. Most of them are in the Denver core facility. USGS has recently reanalyzed these, and so we're looking around the state now and picking areas that we're going to be working with USGS to get their samples and reanalyze them. So here's what we've done to date. I won't go through all this. I pretty much just summarized what we've done in all these areas. And an important thing here is that we are working with USGS and a cooperative agreement so that we can work together to evaluate this potential statewide. Future work, our focus really is on these areas that are open to mineral entry and highest potential. And of course, for the state, we're most interested in state land areas. We're working right now to develop our plans for field work this coming summer. We don't know where that's going to be yet, but those plans are being developed now. We're working to refill positions in DGGS. We just filled 2 positions, permanent geologist 3 positions in the minerals group. And we are currently advertising for, these are temporary positions, but they're probably at least good for a couple of years, a geologist 1. And we're going to be putting out this geologist 4 position with an emphasis on geophysics physicist this coming week. Continuing to build these database, performing geophysics, and then all this data will be available on the DGGS website. So, and with that, if there's any time for questions.
Rod, when you resample or when you reanalyze the DGGS data, are you doing a complete suite of analysis or just looking at rare earths?
I think we're doing a pretty complete suite of analyses. Jen, do you know?
I would imagine it's a complete suite, but I don't know for sure.
Yeah, I think it's much more reasonable cost these days to get a complete suite of analyses than it was, 20 or 30 years ago when they first collected these samples. So we're trying to be as complete as we can, and I think that's a point that is important to know for this entire program. We're not just out there just collecting samples for rare earths and other strategic minerals. We're still considering it part of a whole program because we're looking at the mineral potential, of the potential for all minerals. It just may be that we're focusing on certain areas because that's where we have known localities of these minerals, but we're looking at the whole package.
And I presume you're taking the cut of whatever is remaining, so you can still go back another time later?
Yeah, we're very careful to make sure that we don't use the entire sample when we reanalyze. Any other questions? All right, well, thank you.